All right, so welcome to lecture 10. This is an optional lecture, so attendance is all right. It is what it is. Sorry, I just had a cold, so I'm recovering from it. I'm like 90% there, so sorry if I kind of uh cough a little bit. But I'm basically fine. So announcements for this week. Subsequent lectures and discussions are optional now, so you don't need to attend them, but I think we're going to try to have content that's really interesting. And if you're really interested in iOS development, this is where you get to really be creative and see the possibilities of what you could do with your app. So upcoming tasks, your design doc and Figma prototype is due this Thursday at midnight. Now, we're not expecting like a full-fledged Figma prototype. A wireframe is enough. So just for you guys in your group to have some sort of idea of what your UI looks like. Again, we're not expecting anything like super polished or anything like that. Just to help you guys make sure you're on the same page. The final project checkpoint is due next Thursday, and it's simply just upload your repository. I think there's some instructions, maybe like record your simulator so that we have a clue or make sure it just keeps you on track for demo day. Now for demo day, we're still figuring out the exact dates, but we will try to announce it sometime this week or next week. Again, if you fail to attend, that will result in automatic NP. If you cannot show up, please let us know before demo day. And just please make a private ed thread about that. All right, so this is agenda for today. We're going to basically take a quick introduction of what widgets are, what can you do with widgets. Then we're going to talk about what the kind of code that goes into widgets and what a widget is composed of. And then we're going to talk about how you can create a widget using a WidgetKit extension. And then we're going to do a quick, I'm not going to code a widget from scratch, but some of us in the audience, and we are part of a team under the ASUC called Berkeley Mobile. And we have working on a feature called, which is basically a widget that shows RSF occupancy percentages and also the one in the stadium. So it's pretty cool. We'll show you that in a minute. Any questions before we start? Logistics. Okay, cool. So what are widgets? Widgets live on the home screen and they display relevant glanceable content that users can quickly access for more details. So for example, here in the widgets, the weather widget, you could see the kind of the current weather, the temperature, weather conditions, is it partially cloudy or sunny, and the high and low of that day. And it lets users focus on the information that's more important to them. So in a sense, widgets basically surface key core pieces of information that your app has to the user on the home screen. So users can quickly glance or get information from your app without needing to open your app. Now, there are two types of widgets. One of them is called static. And the data for a static widget shows is dynamic. That means it can't be changed, but the type of data that it shows is fixed. The other one is called configurable. It's a configurable widget. And a configurable widget means that you could change the settings for the widget to change the type or content displayed in the data. So for example, this is a static widget. This is one of the stock widgets. And you can see the type of data that it has. It's just, it shows you the top 3 stocks, the current indexes, and maybe a stock story at the bottom, right? And at a certain future point in time, it will update. So it would show the new values of each stock, and then also maybe another breaking story, shows up and that updates that. But the general idea of this is that the kind of structure and the types involved, right? You have, this piece of UI, this piece of UI, it's the same, right? It's not changing anything or anything crazy like that. The configurable widget is that users can tap and hold a widget, and a kind of pop-up shows up where you can click on Edit Widget, and that shows the widget flips over and it shows system generated UI via developer defined fields, where you can basically choose certain features that you want to show in your widget. And that uses the app intents framework. And we're not going to, again, in this lecture, there's not enough time to really dive deeply into configurable widgets. So we're just going to be focused on the static one for now. But just to give you a sense of what a configurable widget is, so here's the weather app. You tap on Edit Widget, and you can basically select the location of what you want to show for that widget. So now it changes to Berkeley. So that is what we call a configurable widget. And the popover from right here, that is not Swift UI. Okay, this is not a piece of UI that you defined. It's simply a special file that is via the app intents framework, and you basically configure what you want to show up in there. So yeah, it's a bit interesting. If you want to take a look at how you could do configurable widgets, you could, feel free to spend some time on your own about that. But again, for time's sake, we're just going to be focusing on static widgets for today. So the widget gallery is where users can find and discover widgets. So users basically hold on the home screen, the edit mode will appear. You click on the top left corner for edit, and then you could add or invoke the widget gallery. And you could see that it's simply this kind of system interface where you could discover different kind of widgets and things like that. And you could find first-party apps by Apple, or you could find third-party apps that developers have created. And for a given app, right, once a user clicks on one of these widgets, you can see that it enters another popover, or sorry, a sheet, and you can browse different kinds of widgets. So for example, this is a City 1 widget, there's a City 2 widget, and you could see that different widgets also have different sizes. For example, the world clock, right? It has a system small size and also has a system medium size. So these, and again, there's system small, there's system medium. I think there's also system large and system extra large. So there's a lot of different variations of widgets that you could do. There's also a special type of widget called a smart stack widget. And it's simply a system widget that holds a collection of multiple widgets that automatically rotate to display the most relevant one based on some kind of metadata. For example, your current time, location, activity. For example, if you wake up in the morning and you always check the weather app to see what weather is before you put on your clothes for the day, well, iOS will learn from that, and it noticed that you will always open the weather app at around 8 a.m., and it will surface the weather app in the smart stack intelligently. And within our controls as a developer, we could also specify in our code to say, hey, I want the system or iOS to show my widget because something happened or something important happened. So you could basically tell iOS to kind of say, hey, my widget right now, it's actually really important and I want you to show it. So again, we're not going to go into that, but that's something you could do. It's called, I believe, relevances, and you could basically, specify how important your widget is at a current moment in time. There we go. So developers can supply a relevance field to help give some context of importance for iOS to show the appropriate widgets. Now, we can't automatically or manually show it in the Smart Stack. It's just iOS controls everything, so it just takes that value of the relevance field, and depending on the current conditions, it will show it whenever appropriate. So how do we build widgets, right? Let's talk about the tech stack. So the main framework is something called Widget, and that is the kind of the core API where we could specify logic for what is a widget. You could use WidgetKit to build not only home screen widgets, but also Apple Watch complications. So if you ever have an Apple Watch and you can see like custom home or dial faces, you could build those using WidgetKit. You could also build live activities. So for example, when you order an Uber on your iPhone, the live activity will show up from the top, right? It will morph from the dynamic island into this bigger kind of rounded UI, and it will show you when your Uber driver or Uber car will arrive to your destination, right? And that is what we call a live activity. And that can be controlled also via push notifications from a server. Again, that's something a bit more complicated. And also with the introduction of iOS 18, well, in the introduction of iOS 17, you put now widgets on the lock screen in the front. With the introduction of iOS 18, you can now put widgets in Control Center. So there's a lot of variations of what a widget is and what you could use WidgetKit to make. So some additional frameworks. So how do we make the UI itself? That's Swift UI. So remember how I talked about there's another UI framework called UIKit? Well, you cannot use UIKit in WidgetKit or creating widgets. You have to use Swift UI. Now, with the introduction of iOS 17 gave us the ability to have or configure interactivity within our widgets, and that is use Swift UI and App Intents. So, for example, in the music widget, one of the music widgets is that you can now have there's a play button in the music widget, and it will show you kind of the most recent song that you were listening to, and you can click on it right from the widget to play that song. And that is one of an example of interactivity. Again, you can create watch complications via the Watch OS app. Again, there's many more. Configurability, like I mentioned before, smart stacks, widget suggestions, those you will need to tap into App Intents and SiriKit Intents. And for using or creating live activities, you also need to use something called ActivityKit to handle that kind of logic. So app intents, right? It's a framework where you can make an app's content and actions discoverable using system experiences. For example, Spotlight or Siri. So if you want to use something with Siri or you want to show your widget or some kind of relevant information in Spotlight, you will need to use app intents. So some design tips. So Apple recommends that if you using the small widget size, which is the kind of square looking widget, you want to have a maximum of 4 pieces of information. So for example, in the clock widget, you could see it in the small system size widget, there's you could put 4 different clocks of different cities. Nothing more than that. You want to find some familiarity between your apps and widgets. So for example, in the weather app, right? If you open the weather app, you could see that for a particular city, the background is like a gradient, right? That blue gradient. And within the weather widget, Apple uses that gradient background to that widget. So you can see, they're trying to have a sense of familiarity. So when you look at that widget, you know that's the weather app. You could experiment with color backgrounds, textures, fonts, things like that. And you want to, so since you can specify different widgets of different sizes, for example, small, the medium, large, you want to have your layout expand or adapt when the user changes to that certain or that bigger size. So for example, if you're displaying, for example, the clock widget with the system small, right, with a grid of 4 clocks, when you actually change it to the system medium size, it displays the 4 clocks, but now it displays them horizontally, like an H stack. And now with the extra space, you could specify the more information about that city. So how many hours is it ahead or behind, and things like that. You want to avoid putting your app icon into your widgets unless your app aggregates across different sources. So what does that mean? So in the Apple News widget, you will see that there is the Apple News icon in the top right. And the reason for that is because Apple News aggregates or collects a lot of information or data from different sources, for example, different newspapers, different magazines. And so having kind of a consistency of telling the user what it is, you can put like an app icon in the top, somewhere in the widget to tell the user that, hey, this is the news app. I believe the Apple Music widget also shows the kind of note icon as well. You want to avoid putting your app name. And the reason for this is because when you add your widget to your home screen, you will actual iOS automatically displays the app name at the bottom of the widget, just like a any app icon. So if you put your app name, it just kind of it just duplicates, right? It just shows double. So that's not what you want. You also want to avoid putting text for interaction. So you don't want to have a button where you say click me, you because when you click on a widget, you can also specify that it will automatically jump within your app to a particular section and things like that. So you want to avoid putting text to say, hey, click me, or like a button that says, refresh or something like that. And they also recommend that you don't use last updated or last checked verbiage if you want to display the kind of last time it was updated or something like that. So that was introductions about what widgets are. So hopefully you have a better sense of what a widget is. Let's take a look of what a widget is comprised of and how we can create a widget. So here are some additional guidelines. So widgets are glanceable, right? You want to have a whole scrolling list of text, right? You don't want to display too dense information. You want to display a right amount of information that's glanceable, easy to kind of digest. They are not mini apps. So you do not want to put any really crazy kind of UI implementation in there, right? They're just to show information within your app. Widgets are relevant. So a key core of creating widgets is that you want to make sure that your widget is up to date. So again, we'll talk about how we could keep our widgets relevant. And they're personalizable. So if your widget, if you allow your widget to be personalizable, you can create again additional configurations where the user can edit it via app intents. Now, what I want to mention is that you use SwiftUI to build your widgets, but actually you can't use all of the SwiftUI views that are available in your regular apps in your widget. So building widgets using SwiftUI, you are using a restricted finite set of SwiftUI views. So that's a key important thing to do. So I believe you can't use a scroll view in your widget or a list in your widget. That's not possible because widgets, you're only allowed to use a small subset of SwiftUI views comparatively to your main app. So let's define what a widget is, right? So the first thing is the kind of widget. So Apple Music, for example, has three kinds of widgets. So when we're talking about the widget gallery and the user swipes through, right? You can have different kinds of widgets. So recently played, right, might have multiple different system sizes of recently played. And then as you keep on swiping through, recommendations shows up. So it's basically a way to define the UI of a particular or group different widgets of the same kind of context together. The second is your configuration of a widget, and that's what we talked about before with the static and configurable. So when I was talking about configurable widgets, you will need to use the intent configuration rather than the static configuration. And we'll talk about that, what these look like in code. The third is supported families, and this is simply the size. So there are a total of 9 different sizes and type variations. So small, medium, large, extra large. There's also a thing called circular accessory widgets, and those are the ones that I believe show up in the control center in iOS 18, and then also in the home screen, lock screen, sorry, in iOS 17. And a widget also has a placeholder view, and each widget must supply a placeholder variant for system purposes. So, for example, when the user downloads your app for the very first time and the user adds that widget to their home screen, in the widget gallery, if it's fetching information for the first time, right, we want to sometimes place a placeholder where it basically kind of, blurs kind of the UI of your widget out so that it tells the user that's loading or something. Or maybe, for example, when you change light mode to dark mode, sometimes it needs to do some refresh. And during that refresh, it will show the placeholder version. And once it's, the system finishes, then it will query appropriately to display the widget data that you want. All right, so a really key part of widgets is something called a timeline. So we don't want to see a loading screen, right? So imagine the user, looks at your widget and it's loading, loading, loading. That is not what we want, right? Each time. So what we do is that we actually present scheduled snapshots on a timeline. So, and these snapshots, right, can be reused within the widget gallery. And so what you see is rendered in real time. And there's mechanisms in place where you could refresh the timeline from the main app itself. And a really key idea is that widgets are separate from your main app. Widgets are rendered in a separate process from the main app. So even when your app is, you know, you quit your app, right? Your widget still needs to run independently from your main app. So even though your main app is not active, the widget will still be on screen. And we'll talk about what a separate process means in a minute. So timeline. So this is what a timeline looks like. So here we have the widget kit, right? This is the widget kit API. And this is also something called a timeline provider. So widgets have predictable points in time where you can update their content. And you will implement a custom timeline provider. So timeline provider is a protocol that you implement, and you could basically specify it when to update your widget. So a timeline is simply an array consisting of timeline entry objects, and each entry has associated date and time with additional info that you can put in there for displaying. So here, again, here's a diagram of what it looks like. So we have our timeline provider here. And again, it basically specifies, it gives WidgetKit the timeline. So you could schedule, and these right here are timeline entries. So I'll create an entry for what I want to show right now. And then I also want to create an entry to show what I want to show in an hour, 2 hours from now, 3 hours from now. And then again, these are timeline entry objects. And then I wrap them or give it to a timeline object. And I give that timeline object to WidgetKit. And so right now, it will take the first entry, which is the timeline entry that I specified for right now. It will show it. And then an hour later, it will use the 1 hour entry that I specified here. And then 2 hours later, it will show this guy right here. And the third hour later, it will show this one that I specified. I want to show it 3 hours later, right? And then so now we're finished, right? We're finished displaying these 4 timeline entries. So how does WidgetKit know to refresh your widget? Every single timeline has a refresh policy. So there are, I believe, 3 main different types of refresh policies: at end, at after, and never. So right here in this example, we have at end. And what that means is that after we finish displaying the last timeline entry, we will tell WidgetKit to get a new timeline. So again, since we displayed everything here, we're finished. WidgetKit asks your timeline provider to give me a new timeline, and you could show a different timeline from now. So now in this case, we show one timeline entry, which is displayed right now, but we will never, with the refresh policy of .never. So what that means is that WidgetKit will never, or it will not ask your timeline provider for new timeline entries anymore. You could also have a at after refresh policy where you could specify a specific date and time to refresh. For example, now, let's say I replace this at end with at after, let's say tomorrow at midnight. Now, even though we'll display these 4 widgets, right? Now, 1 hour, 2 hours, 3 hours from now, it won't reload right after. It will wait until the date that you've specified. So I said tomorrow at midnight. And then once tomorrow at midnight happens, it will then ask your timeline provider to give me a new timeline. So this is how timeline entries, timeline providers, and WidgetKit operates, right? So just to recap, your timeline provider provides a timeline for WidgetKit. A timeline comprises of an array of timeline entries. When WidgetKit asks for a new timeline, it will display your timeline entries at the specified times. And then a refresh policy is associated to each timeline where it basically tells WidgetKit when to fetch a new timeline via the timeline provider. Any questions so far? I know that's a lot, but hopefully this gives you a better idea of how the system works. Okay, any questions? Good? Okay. So I talked about the reload policy, but let's talk a bit more more depth. So again, the reload policy is associated to each timeline and tells WidgetKit when to reload or update the widget by retrieving a new timeline. So again, at end, request a new timeline after the last of the timeline entries in the timeline has been shown. Dot after, right, you give it a date that you say, hey, I want, basically, WidgetKit will ask for a new timeline at this date. Dot never tells WidgetKit never to ask a new timeline ever again. So to refresh your widget, you will need to refresh it manually via your app. So you will say widget center dot. So these are two APIs where you can refresh a widget manually. So the first one is widget center dot share dot reload timelines. And remember I talked about how you could have different kinds of widgets. So for example, the Apple Music has a widget called recently played. And there's another widget called, I forgot, like album list or something, right? So you could specify, hey, I want to reload the timelines for that specific kind of widget. I want to reload the recently played widgets only. Or you could say, I want to reload all of my widgets. I don't care what kind of widgets. I want to reload everybody. I believe you could also call these APIs from WidgetKit itself. Yeah. So let's take a look about what I mean by a separate process. So what is your app made of, right? So your app, again, this is your main app, and your main app has memory. So this is your RAM, and it basically contains ephemeral data that your app needs. You have your code, and your code here is just basically text or a compiled version of your text, so just binary. So basically, it will load your code, or the operating system will load your code into memory, and again, with your other data, stuff like that, right? And your app might also have other cached data that is part of your app. And this, again, you can think about this as a container. This is your app itself. And this is a process. So a process is a sort of an abstract unit of execution that your operating system manages. So you can think about an app is a process. So for example, this app right here is a process, and that is different from any other app on my iPhone. So each app when I launch is a separate process. Now, how does widgets come in? So here's a widget. It itself is a separate process. So what that means is that the memory, the code, and other data associated with widget is separate from your main app. Okay, so they're two separate things. So what that means is that your widget cannot tap into data in your main app or vice versa. So your main app can't access data in your widget because they're different processes. So one key kind of characteristic of a process is that processes cannot access other processes' memory or other data because they're completely separated by the operating system. And again, there are different techniques if you want to share data. One of them is called app group that you can add as an extension into your application. And that allows for sharing between data between your main app and your widget. But like again, they're totally separate. And so you can't use, for example, you might have a file in your main app called your UI view, right? Your Swift UI view. You can't use that within your widget. Now, there's a way to do that if you add that file to the widget kit extension target. So you could say, I want to use a piece of file in this piece of code within my app in my widget. And you could do that. And I'll show you how that works. All right, let's take a look at how we can create a widget extension. So this is the first thing you will need to do when you want to add a widget to your app. So you need to add a new target to your app. So you go to file, new target, and from this pane, you will select widget extension. And from there, you will, add a name for extension, and there's different configurations of whether you want live activities or you want configuration app intents. But again, for simple widgets, you don't really need them. Um, and okay, so there are different configuration types, like I mentioned before, right? You have static configuration and you also have intent configuration. So this is what it looks like. This is a widget in itself. This is sort of like the at main of your app, right? Or well, it's not even at main. It's sort of like the content view within your app. So this is the sort of the main kind of view hierarchy for a widget. And you can see that instead of some view, it expects a widget configuration. So we're saying that, hey, this is the widget with a static configuration. So we don't expect any kind of configurability within the widget. You will give it a kind, and that is a uniquely identifiable kind of string. And then here you have a provider. So a provider here is simply our timeline provider that we give to our set configuration. And then within this closure, right, we'll get back a timeline entry where we could pass it into another view where we could display appropriate UI given a specific entry. And then here down below, we have some view modifiers. So one of them is called configuration display name. That is what shows up in the widget gallery as the title of your widget. And underneath that, you can see there's a description text. And that is what you could specify down below. There's also this dot supported families. So you could basically specify what size of widgets does this kind of widget support. So you can see that this widget supports the system small and a system medium size widget. And again, you want to use the app intent configuration if you want to use user customization. You want to use the activity configuration if you want to use live activities. Okay. So this is what a timeline entry looks like. Okay, so timeline entry and timeline provider are protocols that you will need to implement your own as custom, not subclass, but implementations. So for example, here is a game status entry. It requires a timeline entry requires a date, so you'll need to specify a certain associated date to that. This is optional, but it's simply remember how we talked about that you could supply relevances to tell iOS, hey, right now this entry is really important, and I want you to show it in the smart stack. But again, like I mentioned before, you can't specify it to show it exactly at a given moment in time. iOS will take your relevances and also other relevances from other apps and appropriately show it whenever necessary. And then within this game status entry is other relevant data that you will need to manage, like for example, your models. And so if you want to provide relevance, you would create an instance of timeline entry relevance with the score property. And so the score property is simply basically a decimal. And how does iOS know when a particular entry has a higher relevance to your prior entries? It takes your decimal value that you provide here and it basically compares it to the other timeline entry relevances from other entries that you have given it before. So this is sort of a timeline provider. This one of the methods is get timeline. And this is how WidgetKit actually queries your timeline provider to give me a new timeline. So you create a new game status and new timeline entry here. You specify the date that you want this entry to show. You will create a timeline object with an array of entries or timeline entries, and you give the timeline a policy. So in this case, we're saying to tell WidgetKit to once this entry shows, we will refresh after this date. And then we'll call this completion handler to give WidgetKit this timeline. All right, so that was a quick overview of how you want to get started to create a widget. Now I want to kind of show you a, a real life example of a widget. And this is from Berkeley Mobile. So we're going to exit out here. Um, uh, so, okay. So this right here is, I guess, sort of looks, everything looks squished. So this is an example of one of the apps that, again, several of us are part of here. And one of the features is that we always been wanting to create a widget to show the gym occupancies from the website, right? The RSF, weight room meter on the website, and we basically scrape that. And then we have a widget that displays the gym occupancy for that given moment of time. And also, comparatively from the last time entry or the last widget that we showed, did it increase or decrease or did it stay the same? So this is what it looks like in a file hierarchy. So after you did file, new, target, and then you do widget extension, right? Once you do all of this, what you see is that Xcode gives you a new file called whatever widget that you named it, and it gives you this kind of template file. So it gives you these four files, an assets folder, right? Again, this assets folder is different from our main app assets folder. And the reason because this is that a widget is a separate process. It cannot access stuff in your main app by default. Here is the kind of the main app analogy for widgets, right? So this is the kind of the entry point into our app. Now, if you have different kinds of widgets, you basically just put it down here. Um, but for the current app that we only have one widget, which is called Gym Occupancy Widget. And this right here is the code for that gym occupancy widget. So this is sort of the similar kind of code that I showed in the slides, right? So this kind of widget is a static configuration. We give it our custom provider, and I'll show you in a minute. And so we display the widget view or UI. And here we have the exact sort of the view modifiers that you want to configure our widget to have in the widget gallery. So now let's go up to see what the gym occupancy provider looks like. So here we have some custom data types. So this is our timeline entry. And you can see that this is a timeline entry. It has a date and it has relevant data that I need to drive a timeline entry, right? So I display here the tuple of the prior percentage and the current percentage, right? And that's how I can calculate if the current percentage has increased, decreased, or stayed the same in comparison to the prior one, right? Okay. And then I'll talk about this in moments, but here is the gym occupancy provider. You get to see it here. It has several additional functions. Here's a placeholder, and that is what's being shown when, for example, when the system, basically updates and it needs some kind of placeholder to show it as it queries, your main data for your actual widgets. That's what it displays. Here is a snapshot, and the snapshot function basically gets called when your widget shows up in the widget gallery. It basically calls this get snapshot function, and it displays it in the widget gallery. Here is a timeline, right? And this is the data or logic that we basically gets called when WidgetKit requests a new timeline for it to use. And so here we can see that I have this helper function that basically fetches the RSF occupancy percentage, the Stadium occupancy percentage. I create a new entry. Right now, I'm just displaying one entry at a time because I can't predict future percentages in the future. So I'm just showing one at a single time for a single timeline. And then I pass it as an array, and I basically tell the policy, say, hey, after you show that entry, request a new timeline right away. And that is what I'm doing here. And I'm passing it the timeline back. And so you might see that I have this entry cache. And this is simply a way for me to kind of keep a pointer, or just basically to keep the prior entry in memory. Now, the reason for this is because this is a struct, it's not a class. So I can't have just a variable here and update that variable because I can't, you know, by default modify or update properties of a struct once it's been created. So you can't update a struct instance from within itself once it's being initialized. You just can't do that because structs are the conformative value semantics. So here, the snapshots here, uh, here it gives you the context. And so this context dot is preview. What that tells you is that if the widget is being shown in the widget gallery. So what I'm saying here is that if if this snapshot is being shown in the widget gallery and occupancy percentages are not available, I will show it via these default values. So I'll still show something, in the widget gallery. Of course, they're not accurate information, but I'm just showing like placeholder data. And then if I do have occupancy percentages, I will like fetch it from scratch, and this is what I'll show, which are the actual live data of that widget. So, and then here is a gym occupancy widget entry view, and this is simply the actual UI for that widget. And I basically get an entry here. And where am I actually creating this instance of this view? And where am I passing an entry into here? Well, that is right here. So within the static configuration closure, right, I get a timeline entry. And what is the UI I want to show? I basically want to show my widget entry view, and I pass in that entry with the associated relevant data that I need to display the UI. All right, so now let's take a look at the previews. Now, the previews look a bit different from your regular SwiftUI previews in the main app. And the reason for this is because you can specify a timeline of your entries. So for example, now I can basically cycle through these particular entries at different points in time to show what it looks like for the user. So again, these are all sample data. So here you can see we have our simulator, well, sort of a simulator, and you can see our beautiful widgets. And down here below, it's a bit kind of pixelated, is our different UI views for each entry that I specified here, right? These are timeline entries, right? So at a given point of time, right, I'm showing this widget right here with 93, 40. The priors are 71, 68. And you can see from the priors that since the current is 40 and before was 68, I'm showing this down arrow, right? So now I could actually play this, and you can see that it goes from one entry to the next. You can see it animate, it updates. I'm also showing the time when it was updated and so forth. So this is a great way to kind of prototype your widgets, to create widgets. And yeah, you could also see it on different sizes, for example, system, medium, things like that. So that is a quick overview of what widgets are. Let me just quickly go over slides to summarize everything. So widgets display relevant glanceable content that users can quickly access for more details. You can use widget to create watch complications on watchOS, live activities using Activity Kit, and control center accessories, also the lock screen as well. You can use the app intents framework to make a configurable widget. Otherwise, it's static. You can define the kind of widget it is, the type of configuration, supported families for a widget, and also a placeholder for the widget. And you can create a timeline using the timeline provider. And the timeline contains timeline entry objects. And each timeline has a specified reload policy where it tells uh, basically WidgetKit when to reload or when to fetch a new timeline. And you can use the Widget Center APIs to force reload timelines manually from the main app or also in the widget itself. So yeah, that is widgets. Again, this is a lot of information, but I'm sure there's a lot of resources that you could find online to help you. And yeah, this is a great way to kind of really elevate your app and to really, you know, kind of your opportunities for what your app really is kind of, it's limitless from now on. So yeah, this is real cool. And if you use a widget in your final project, you get 100 extra points. So just kidding, but it is. We'll take that into consideration. So instant prize, right? That's the so yeah, cool.